My name is Peter Fournette. I'm with Polyurethane Foam Systems Incorporated, a division of Demilec. We're going to talk about designing an efficient, durable building envelope. So we're going to talk basically about spray foam insulation and how it fits within the industry. So we'll talk a little bit about the history of spray foam, its origins, where it came from, how it came about to be within the industry. We're going to talk a little bit about physical properties, typical building construction details, and some of the building code. Not very much on building code. I mean, you know, there's constantly changes within the code, so we'll see how that goes. So the history of spray polyurethane foam was first invented in 1939. You guys know the Bear aspirin. Everyone's taken a couple of Bear aspirin on a Sunday morning, I'm sure. Dr. Bear invented spray foam. It was first invented in 1939. The very first use for spray foam in any form of construction was during the war. The Allies would fly over Germany, they'd bomb the runways. The Germans actually went out, put foam in them, painted it gray, and then the Allies would fly over, and they would think they completely missed their targets because the runways looked perfect. They weren't serviceable, but they looked good from the air. And it was a bit of a deception, and it was a great tactic. And it was one of the very first uses of spray foam in construction, as we know today. So the very first time spray foam was used in construction was 1968. It was the first time it was adopted into the National Building Code and used within building construction. So that's over 46 years that we've seen it in the industry now accepted. And it's governed by the CAN ULC S705.1, which is the construction manual for spray foam. So there's a couple of different regulations that govern spray foam. So we want an envelope design very much like a freezer. We'd like to keep, you know, the warm air in our house, we want the cold out, and in the summer we want the opposite. So house construction now has been very much designed like a freezer. You know, we insulate it, we stop air transfer, that's how we can keep the cold in. You know, the kid stands there with the fridge door open for 5 minutes, you're always screaming at him, shut the door, you're letting all that warm air in and the cold air out. Well, it's the same thing with our homes. If you put a hole in the wall, you know, a doggy door, a hole in the wall, open a window, you're gonna lose all your heat. You're gonna get heat transfer. So foam insulation is designed to seal the house. So we see that. We have urethane in everything around us throughout our day-to-day. Those seats you're sitting on have a urethane foam in them. We see it in golf clubs. You know, you probably golf. I'm sure that you do a little golfing. So the heads of your golf club, they're filled with an injected urethane foam now to weight them and balance them out. Car parts, dashes, 90% of our car interior, urethane foam. All the different types of beds on the market, they're a form of urethane foam, different degrees. So we see that in our everyday life. So we're going to talk a little bit about foam and construction. So we're going to talk about sprayed applied foam and injected foams. So spray applied foam is exactly what it says. You have a spray gun and they spray the foam into the building cavity or the wall assembly, and injected foams are injected. So we'd see that in steel core doors, garage doors, some of the newer polyurethane window frames are an injected foam. Some of the aluminum frames are injected foams. So that's where you see all that. So we're going to talk about spray foam. The first application again was 1968. That was when it was first adopted, over 46 years ago. It says 30 years here, but it's actually 46 years since 1968. So foam for air sealing only. We've all gone to Home Depot, bought a can of that great stuff that you spray and put it around the windows and doors. That's an air seal. It's not an insulation. It's for air sealing around windows and doors. They're governed under the CAN ULC S711.2. So there's rules that govern how that foam would use. They can be a two-part component or a single component. So single component's just a spray can. You would spray it. It would rise. You'd fill in around your window. A two-part would be like the propane cylinders you see there. A and B, they're mixed and sprayed in around the windows. That would be more what a contractor would use. Again, they're only for bead applied around windows and doors. They're not an insulation. They're an air seal. It's just to keep them separated, because people always say, well, I'm going to insulate around my windows. Well, you're not really insulating, you're stopping air seal. So one of the foams on the market today is a low density foam. So low density foam would be considered a half-pound foam, or low density is exactly what it is. So it's very porous, it's soft to the touch, you can touch it. A very low R value, 3.8 per inch would be the R value of this spray foam. So it's got a lower R value. The foam can only be used in a wall cavity indoors and above grade. So it's not for outdoor use, it's not for below grade. is how it was designed to be used. It expands 100 times in the cavity. So they would spray it in, it would fill the cavity, they just cut off any extra. So again, our 3.8 per inch, and that's governed by the Canuel C S712, the same as the air seals. They fall under the same categories. Then we'll talk about medium density spray foam, or 2-pound foam as you would hear it. So medium density foam is a 2-component foam. It's an A and B mixed together. It's a rigid with closed cells. Now it has one of the highest R values in the industry, an R6 per inch. So for every inch of foam, R6. It's rigid, it fills the cavity, makes for a great insulation. Expands 30 times its volume, and it can be sprayed at temperatures between -10 and +40. So in the climate of Canada, it makes it very usable within the industry. So high density spray foam would be a 3-pound or better. So we see 3-pound foams used in industrial applications, industrial roofing. We'll see 5-pound foams used in different applications. And in the oil field, we'll see 10-pound foam used for pillow blocking for oil pipes. So there's quite a wide variety of poundages in foams, and they all fit within a scale, you know, from residential, commercial, industrial. So we see that throughout everything. So roofing, water tanks, water storage systems. Application procedure. Well, spray foam is exactly what it says, spray applied. So it's 2 components, an A and a B. They're mixed at a gun through a reactor proportioner, and then it's sprayed on. And they have to have specific temperatures to apply it. So minimum thickness, 50 millimeters that they would apply. And temperature application, again, between -10 and +40. And we can see on the, I guess that would be the right-hand side of your screen, this would be an applicator applying spray foam to a building. And then the center picture would be the inside of one of their spray rigs. So very portable, easy to use. Some of the added values to spray foam that we see in the industry with our product is renewable products. So we use soybeans to help cut down on use of petroleum products. We have recycled content, so 18% post-consumption and post-industrial. So a lot of plastic bottles are used in recycling with our products, and there's some water added into that as well. So we minimize our carbon footprint by making it as green as possible within the industry. We are the only spray foam made in Canada, and that uses 18% recycled content. So Canadian product with recycled content. So product standards, what makes spray foam you know, a type 1 or a type 2? I'm sure some of you guys have heard that. Oh, it's a type 2 spray foam, it's a type 1 spray foam. Well, there's only one type 2 spray foam on the market currently, and that's Polar Foam 7300, made by Demilec and PFSI. So it's a 2-pound foam. To become a type 1 spray foam, you would have to meet 13 physical properties laid out by the NRC, the National Research Council of Canada. They have 13 physical properties that you would have to meet. That's what makes you a type 1 spray foam. When you exceed all 13 physical properties, you become a type 2 spray foam. So Polar Foam is the only type 2 on the market because it exceeds all of the ratings. And it has the highest R value in the industry. The application standards. Well, the National Standard of Canada has a Canuel C S701.2, which governs how spray foam is applied and installed. The governing body that looks after spray foam is called CUFCA. They are the Canadian Urethane Foam Contractors Association. So contractors need to be licensed and registered through CUFCA. They go through an extensive training program, they become an apprentice, and then they spray the foam at that point in time. So a certified medium density closed cell spray foam installer would have a badge like you see up here. So he would have a little ID card with his photograph, tells you when he was certified and what he's certified to spray, whether it's medium density spray foam or 1/2 pound spray foam. So that's something as a homeowner you would want to ask that question. You know, are you a certified spray foamer? And if he says, yes, I am, say, I'd like to see your identification. Are you CUFCA certified? If he says, no, I'm not, I probably wouldn't use him as a contractor. That means he's using maybe uncertified foam that's not regulated in Canada, you know. So you would want to ensure certification. That's one of the nice things about CUFCA. They do training back east. They're trained extensively. They're taught building science, the science of the building, how the building is managed. So medium density closed cell, they do job site documentation. So on the far right-hand side of the screen, I guess left-hand to you, would be a symbol of quality. They stick this on your electrical panel. that would be the CCMC number, which is the Canadian Constructions Material Number for the product, the batch numbers, when it was sprayed, who sprayed it, and their license number. So in the future, when you go to sell your home, that adds value when you sell your home. They'll say, yes, it was spray foam insulated by a certified installer. They can always look at that. All the documents are registered with Kafka. So they would fill in a daily worksheet like you see in the middle here. So they would mark down the batch numbers, what the ambient air temperature was, what the substrate temperatures were, when they sprayed it, how it performed, and what their R value they were achieving. And that's all documented and forwarded to Kafka and kept on file. So at any time, if you buy a home and it has a Kafka symbol on it, you can go to Kafka and say, hey, I purchased this home, here's the installer, could you tell me a little bit of information about it? So it validates it and you know, gives you a greater value in your home. And then we have the Kafka worksheet on the other side. So all of our products are manufactured on site. So they're an A and a B, so the contractor in fact becomes a manufacturer. So he would spray the product. So he would spray about 3 feet, and then he would test the product to make sure that it's performing in the manner it was meant to be performing. So he would have a test kit. He would check the density of the foam to ensure he's meeting the standards. He would check the adhesion, the cohesion to make sure it's sticking to itself and the substrate, and that it's fitting, you know, doing what it's designed to do. So that's all documented again on those worksheets, and it's done usually at the start of the job and at the end of the job to ensure quality assurance. So we can see here on the one photo, they've got a weight hanging off the thing, and that checks the adhesion cohesion. So that product has to stick and be able to hold a 2 kilogram weight on it. So if it pulls off the wall, the substrate, it's not adhering correctly, and they would stop what they're doing, figure out why it's not adhering correctly. And that way you get the best quality because it's tested right on site by the contractors. And they're trained in that specifically, whereas an uncertified installer probably wouldn't be doing this type of testing for you. And thickness control. So you've asked the contractor for 3 inches. So they would do thickness control as they're spraying. They would constantly test it in a grid to ensure that you're meeting that standard. And then you wouldn't be getting ripped off, so to speak. You know that you're asked for 3 inches, you've received 3 inches. So properties and functions within the building. Well, as an insulation, it's a type 2 insulation, which is the highest level, and you can achieve an R6 per inch with a type 2 insulation. So as an air barrier, at 25 millimeters, 1 inch, it's 500 times greater than what the National Building Code requires as an air barrier. And as a vapor barrier, it has less than 60 nanograms of perm rating at 38 nanograms of perm, so it acts as a vapor barrier. So you have a vapor barrier, an air barrier, and an insulation all in one. So there's no need to have a vapor barrier over the product. So you create a nice seal with that product. So insulation properties. Well, we can see a type 2 insulation. Initially when it's sprayed, it's 7.2 per inch when you first spray it. So after 180 days, it becomes R6.6. But what we're looking for, and because I do these presentations mainly for building officials, architects, and engineers, what they're looking for is the long-term thermal resistance, the life of the foam over its whole life. So they would be asking, what is the LTTR of spray foam? And that's the question you would want to ask a manufacturer. What is the long-term thermal resistance? Our product is an R6, and that's the true insulating value. So they can tell you it's R8, it's R7, it's R6.9, doesn't matter. It's the LTTR that's the important number to remember, is what is the R value over the life of the building. R6 is the highest in the industry with polar foam. And it is a CCMC approved product, so you can see 13244L is our CCMC number. You can go to the National Research Council website at any time, Google it, type in that number, and it will tell you all the specs on that product specifically. So if you happen to have a competitor who says, oh, we're certified, ask them for their CCMC number and then put it in there, and you can do direct comparisons to the product. So continuity in airspaces. Well, one of the reasons we have air leakages in our home is because there's no continuity. You know, we have gaps, we have leakage. As we can see here, how do you seal these gaps to stop air leakage? So you're gonna have air leakage in your home. That's where your heat loss comes in, is through air leakage. So you wanna seal up those gaps to prevent air leakage. And again here, these laps need to be taped. They should have been offset. With spray foam, you don't have that problem. You have complete continuity in your whole area. So air barrier properties. The National Building Code 2005, parts 5 and 9 require an air barrier system. So gypsum board acts as an air barrier at 0.02, it's an air barrier. Spray foam is at 0.00004, which is 500 times greater than what the National Building Code requires. So as an air barrier, it's a great product. You can't beat it for an air barrier system. It's self-adhesive, it's rigid, it's structural, it seals every joint in your house so you don't have any air leakage. So air movement versus air barrier. So what causes air movement in your home? Well, you get wind effects, so you have wind on one side, creates a high pressure. You end up with low pressure on the other side, causes air leakage. You have chimney effect, so just the air stacking up inside. Combustion and ventilation, we have fans, we have vents, we have light plug holes. Air is always leaking out of a building. So with this product, you become an air barrier system. You eliminate all of that leakage. And of course, you maintain your heat. So an air barrier is 100 more times important than a vapor barrier. So a vapor barrier might allow 1/3 of a liter in, through diffusion. If you had a vapor barrier and you punched a 2-inch hole in it, you could allow 30 liters of moisture into your home through a 2-inch hole. So you want to stop air transfer, not necessarily the vapor. The air barrier is the key. This is a great picture. How many people have a fiberglass filter in front of their furnace? Pretty much everybody. I'm sure that's what everyone uses. You buy them a Canadian Tire, it's a nice fiberglass filter. Why would you insulate your home with something you use as a filter? It doesn't make any sense. I mean, you use fiberglass in your walls. So the people in this building didn't breathe any dirt because this acted as a great filter. You can see all the dirt that accumulated at every place that the air was leaking out of this building. This was torn off and redone with spray foam to stop the air leakage. So it shows you how much air leakage a building can have over time. So everyone's familiar with the leaky condos in Vancouver, the EFIS systems they used. I mean, it was a big catastrophe. Every building was leaking, we had mold and all those problems. This was a 5-year-old condo in Vancouver that was retrofitted with spray foam. So we could see the mold just starting to grow inside this area here. It was building and growing. It was retrofitted with polyurethane foam. They had to tear it all out. Of course, they had to put the shroud of shame over the building and then spray foam it. We were all familiar with it, but that was the only way to fix the problems because of the penetrations within the building. Durability. This is a school in Alberta that was spray foam 5 years ago, and we went back and left an area that we could go and investigate after time. So we can see here, the pink fiberglass is as pink as the day it went in. We can see a conduit that's going through the wall into the school, and that was never taped up. So that would have been a potential air leakage point. But it didn't leak because the exterior of the building was spray foamed and sealed, so there was no air leakage. So of course you can't get any dirt within the voids, and you have no transfer. So that insulation actually does the correct job on the interior walls when spray foamed on the exterior. And that's a commercial application. So just to point out, our product is Green Guard certified for schools and hospitals, and that's the highest standard. California set the standard extremely high, and we are the only product that can meet that standard to be used in children's schools and hospitals. So the product performs well, provides great results. We can see all of the air leakage points in a house. With spray foam, these areas here don't leak, and we can see on the other side, your rim joists, your sills, your joints, through the siding, the insulation, electrical outlets, pot lights. These were all potential leakage points for air to get into your home and for hot air to get out. So when you spray foam, you create seals around these, eliminating those potential leak points in your home. Of course, creating better energy efficiency. So you could save 30 to 60% on your heating bills by insulating with spray foam. Continuity and a water seal. So this is a commercial application. We don't see this on homes that much. Mostly back east we'll see it, and I'll show you a slide of that later. This building here is spray foamed on the exterior, and we can see it goes right over the flashings, and it's spray foamed underneath the flashings to create a perfect water seal. So water can't penetrate that building. The foam is 100% waterproof, so it doesn't allow for that. So some of the system features, well, membranes can be installed at -10 to +40, so can spray foam. You can spray it over flexible flashing, Z-bar, copper pipes, PEX pipes, ABS, it doesn't matter what type of pipes. It can be sprayed in all types of thicknesses. It's supported by many other types of products, dense glass, OSB, so it can be sprayed on a variety of things. The only thing it won't stick to is poly. So they poly the windows, and because you don't want spray foam to stick to it. But spray foam sticks to absolutely everything. It's got great adhesion properties and great insulation properties. As an air barrier system, well, our wall assemblies have to be tested by the National Research Council of Canada. They go in, they set up these false walls, they put in all types of protrusions, different types of blue skins, flashings, brick ties, Z-girts, pipes, and then they bring the temperature down to our tested level of -10. They're showing it there at -9. They bring it right down to -10. Then they have an applicator go in and spray foam it, and they see how the product performs. You can see here an applicator applying the foam at those temperatures, and then they see how well it performs around these protrusions, and they pressurize that wall to see if there is leakage, and that's how they determine our ratings through the National Research Council of Canada. And then they give us our CCMC number for approval for construction in the industry. So wind and rain, well, we live in a tropical rainforest in British Columbia, so we're considered extreme weather out here, even though we don't get snow, but we have lots of extreme weather. The interior of Canada, pretty much sheltered. The coastline a little bit moderate, but basically, the East Coast and the West Coast are considered extreme, and that's one of the advantages of using spray foam in these areas. So water absorption. So the ASTM D2842 water absorption tests, they immerse products in water for 96 hours and then pull them out, see how much water they absorb. So spray foam absorbed 0.8%. So basically they put it in 96 hours, they pull it out, they shook it off. That's all the water that it absorbed. Mineral wool, they put it in for 96 hours. 32% water retention. That's a lot of moisture to be in your walls. You think if you have a leak and that goes in, how do you get rid of it? It's almost impossible to get rid of that. So 32% absorption on other products. And we can see here on this building that was done in a mineral wool fiber, these dark areas is water that's laying inside the hat track. So when they come and put cladding on that building, they have to wait for it to completely dry out before they can clad it. So this is why we had problems with leaky condos. Moisture gets trapped inside, you can't get rid of it, unfortunately. So as a vapor barrier, National Building Code states a vapor barrier is when it has permeance of 60 nanograms of perm or less. So a 2x4 stud is at 46 nanograms of perm, and our product is at 38 nanograms of perm when applied correctly. So condensation versus a vapor barrier. While hot, humid air wants to move to a cold surface, and then it creates condensation, you eliminate the potential for a dew point when you spray 2 inches of foam in a wall. It cannot form a dew point and have condensation happen. So that's one of the beauties, again, of spray foam. So functions within the building: insulation, air barrier, and vapor barrier. So it's a great performing product. One product, 3 functions, gives you energy savings, cash in your pocket. I mean, if I could save 30 to 60% on my heating bill for the rest of the life of my home, of course I would insulate with it. It would make sense. Chances are you're gonna want to change the carpeting in your house in maybe 10 to 15 years. You might renovate a kitchen in 20 years. You're never going to tear out the drywall and re-insulate. So why not do it right the first time? Insulate your home correctly, save the money over the life of the building. Some of the other properties of spray foam, well, it's resistant to moisture, oil, solvents. It's inert, doesn't create or absorb any odors. So it doesn't off-gas, it doesn't create odors, it doesn't absorb odors. It's very inert, it's stable. It's a green solution, doesn't support any fungal growth. So for mold to grow, what do you need for mold to grow? Well, you need air, water, and oxygen. So you eliminate one of those, you've eliminated the potential for mold growth. Spray foam doesn't support fungal growth. It's a polyurethane plastic, so mold can't grow on it. So you're never going to have a mold problem in your walls when you use spray foam. That's one of the great features of using it. You eliminate the potential for mold growth in your home. So no waste, no packaging. So they come in renewable totes or 45-gallon drums. So 2 totes, like a set, it's called a set, can do 2 houses. So our carbon footprint is quite minimal compared to all the others when you look at it overall. And if we're start to look at things globally and how we help the environment, yes, we're a petroleum-based product, but we're as green as we can make it. We use recycled plastics. We have some soya product in there. We're using some water content. And our global footprint is minimized, so our carbon footprint is reduced. So a great transportation cost. So one truckload of our product, it would take 19 truckloads of rigid board to equal the same amount in comparison. Now think about that on a big, huge construction site, what the carbon footprint now becomes for extruded versus spray foam. So again, in the big commercial jobs, it minimizes our carbon footprint. So certification program, we are Green Guard certified. I said that earlier. For schools and hospitals, we are the only product that's Green Guard certified. Residential high rises. So the speed of a construction job is something that's very important sometimes on the site. This was done in one day, the whole building, with 3 trucks. And they just used the mason's jacks. So they were able to come in, 3 trucks, one day, spray foam the whole building. So it really sped up the job site. They were falling behind, time constraints were happening. They went to spray foam, it eliminated some of their costs. And again, we can see in this shot here, they're using the mason jacks. And that side of the building was done in about half a day to literally spray foam that with 2 guys. So it does really speed up the process in construction. Institutional, so schools. The #1 user of spray foam in schools is Alberta. They spray foam, almost 90% of their schools are spray foam, which is great that we see that happening now. We're starting to see schools being done, drugstores, London Drugs now is doing it, Target and Walmart are starting to go, hey, we need to save money on our energy costs because it's how do you heat these huge, huge buildings? It's astronomical, the costs. So by using spray foam, they're starting to minimize their costs, conserving energy. They see it in their end. And hopefully, they pass the savings on to us. We know Walmart's always dropping their price. So must be because of the spray foam. All the energy savings, they want to pass that right back to us, which I appreciate them doing that. Residential. #1 user of spray foam in Canada is Quebec. 98% of all homes built in Quebec, spray foam insulation. Now, mind you, our parent company, Demilec, is in Montreal, right? We're a Canadian company, so Quebecers tend to use Canadian-based products. They're the #1 user of Canadian-based products in Canada. I wish the rest of Canada would be that way. We'd be doing great business then. But they do spray foam all of their homes. And they do them inside and outside. As we can see here, the exterior of this home is spray foam. It's also spray foamed on the inside, so they do strapping. Because they do have quite an extreme climate in the area. As we see, Northern Ontario, Quebec, very extreme. Segault Village, Quebec, latitude 62, very northern. Everything in that whole village is spray foam. Their water storage tanks, all of their buildings, everything's spray foam. One of the furthest northern areas, just about next to Ellesmere Island, which we have a radar tech station the military has up there. They fly the product in with Hercules aircraft, and they spray foam everything because it can sustain the temperatures that are conditioned up there. Agriculture. Alberta's #1 user of spray foam in agriculture. So the Potato Growers Association of Alberta recommends that all their potato storage facilities be spray foam. Because it doesn't support mold growth, it makes for safer potatoes. The Lay's Potato Chip Factory, just out by Tabor, Alberta, they have a huge storage facility, all spray foamed. And again, it doesn't support mold. So there was actually a gentleman asked me the other day, he says, we're looking to store fruits and vegetables. What would you recommend? And I said, well, I'd recommend spray foam because it doesn't support mold growth. So you want to make sure your root cellars, if you have a root cellar, be spray foamed. In case there's a tornado, you want to get to the root cellar. Just kidding. So these are some of the applications we see within the industry. So who installs pink fiberglass insulation on the job site? Who does that? Usually the lowest man on the totem pole, right? The least qualified person is doing the most important job on your home. I find that amazing. Same with Blueskin. That's the most important detail on a big construction job site. And they have the lowest guy and the cheapest labor they can to install them. So this is an improper job that would just be torn off. We want to seal up these sort of areas with foam because it's a very difficult detail to air seal. Spray foam can completely seal that. So when you get your home insulated, you know, are they splitting the bats? Are they putting them in there, making sure they're just right? They just stuff them in the wall and they leave. With spray foam, our contractors have to be certified and they're regulated and governed by standards to ensure that you get the best insulation in the industry. So why would you want, you know, the worst person to install the most important product in your home? It doesn't make sense to me. I want the most qualified person to do it. You wouldn't get the laborer kid to do your electrical or plumbing, right? You want a certified guy to do it because those are important parts of your home. So of course you'd want a certified installer. And that's why we put a lot of time into training and education. So this is a commercial membrane over Z-bar, and you can see how spray foam creates this great seal. So the membrane goes down, there's spray foam underneath the membrane, and then they seal right over top of it. So we know there's never going to be water leakage at these type of details. Now again, this is an architectural detail that I mainly talk about with architects. We do a lot of through-wall flashings that are very specific, and spray foam was really the only answer in these big commercial buildings on how to do them properly. And we're just starting to get into the residential aspect, and we're seeing it more and more mainstream residential. Complex roof designs. While spray foam is really the answer for any roof design, in my opinion, how would you ever insulate that with bats and seal it up? It'd be almost impossible. That's a detail that would be hard to do. And we can see here in the vaulted part of this ceiling, very easy to do. A lot of people are now placing their HVACs into the attics, so they're insulating them in the attics, making some changes. This here would be cardboard baffles for ventilation. They spray foam directly to it, creating ventilated ceiling space that's well insulated. A very great detail to have. And then this is a residential cathedral ceiling done from the outside. So they do all of their woodwork on the inside, spray foam from the outside, creates ventilation, and then the strapping and the sheathing goes on over top. So it's kind of done in reverse, but it's the right way to do it. It makes sense to create ventilation in there. And large industrial ceiling complexes, again, spray foam from the underside rather than from the top side. So they tar and gravel. This creates an air seal, a water seal, air barrier, vapor barrier, all in one. Rim joists in your home. How many people have cold floors, you know, at the edge of their house, in their crawl space? It's because they're rim joists. How do you seal that up? When you think about putting in a bat into that void and then having to poly over that and seal it, that's a very difficult detail to seal up, where spray foam fills those voids, does a really nice clean job, and eliminates air leakage around the rim joists of the house and crawl spaces. As we can see here, the rim joists all completely done, all the walls are done. So as a drainage plane, foundation by exterior. So spray foam could be used on the exterior. So above grade, below grade, inside, outside, on the ground directly. Spray foam can be used in all applications in a 2-pound, in a 1/2 pound indoors only. Again, you know, make sure you know what the product is. So they would spray that on the exterior wall as a drainage plane and then put in your weeping tile and your gravel. So no need to put tar and pitch on the side of a foundation anymore. This is common back east, although we just had a house in Victoria. This is called a rubble style foundation, where it's all rock. A lot of water penetration in these style foundations if you don't have great drainage. Very difficult to seal. So back east we see all of these done in spray foam to seal them up to stop the water penetration going in. And then they, of course, new perimeter drains and seal them back up. And we just did one here in the city of Victoria. So here we see a foundation, spray foamed. The nice thing about spray foam, once they're done, you can backfill directly to it. And immediately. So he could literally spray foam a wall, go around the corner, and they can backfill to it. Spray foam is dry to the touch within 3 seconds. You put your hand directly to it, it's dry. Under the slab. So this is becoming a more and more common practice. We're seeing under slab. We see it on the interior of British Columbia more now for radon control. So everyone's familiar with radon gas happening. So the Okanagan Valley is mandated they have to have ventilation under their slabs and all these fans and pipes to capture the radon gas so it doesn't end up into your foundation area or in the basement of your house. So what they've now done is we spray foam under the slab, right to the ground. They pour their concrete, and then it's carried up the wall, and then they stud the walls, and then they just carry it right up the wall. Completely seals the foundation and creates a very cozy basement atmosphere. And this would be a new construction application only. So here we have on the one side, spraying directly to the ground. We recommend a minimum 1.5 inch spray directly to the ground. It seals around all protrusions completely. You can put boxes around areas that need to be done. Perfect continuity, radon control. It has a rating of 28 psi, so you could literally drive a truck over it if you had to. It's not going to compress down and squish. Very high psi rating on our foam. And again, if you were doing radiant in-floor heating, you could spray foam directly to the ground, lay your heating pipes, and then pour concrete over it. Again, a very efficient way to do it. You don't have the problem with laying down rigid panels, walking on them, they crack, they break, you got to tape all the joints, then you have to put poly down to make sure that it's sealed up. It's very labor intensive. This makes for very quick application. Speeds up construction and minimizes costing again. And it's just another application. You can see he's carried it up the wall slightly, so when they pour the concrete and they stud the walls in the future, they can tie it right in when they spray foam it at a later date. And this would be in a condo situation where they have parking garages below the condos. So spray foam needs to be thermally protected by building code. So if it couldn't be drywalled, which in this case it couldn't, it was a concrete wall, they sprayed the foam and they just put a thermal coating over top of it to protect it. So just showing you a little bit if there was some people with condos or condominiums thinking about doing something. This is a great project. This was the Verdun triplex in Montreal. It's a net zero energy building, so they don't use any electricity in this building. It's all solar and passive. We spray foamed this complete building, and then we did thermal imaging on it. And it's quite dramatic when you see it on this next slide. So there's the thermal image of our building, and we can clearly see the window frames is where your heat loss is. Those bright white areas is the aluminum in the window frames. So they're a high energy efficient window, yet you see the heat loss coming right through the aluminum part of the frame. But look at the building just behind it, right in here. You see the bright areas, the heat loss of that building, and the one on the far side, that's heat loss of that building. So we can see how well the insulation works on this building. It's completely sealed. There's no bright spots other than where there's a little bit in the glass. So if that had been maybe, instead of an aluminum window, maybe a wood frame window, you might have minimized that heat loss. But that's still a very minimal amount of heat loss when you compare it to the building behind it that's glowing orange. So I find that to be a very dramatic shot. I just love it to look at it and feel, wow. You know, I wish my house would be that energy efficient, which it is because it's spray foam, but you know, everybody's thinking the same thing, right? I need energy efficiency like that, right? That would be some great savings in that building. So 100% self-adhesive on every substrate, 28 psi adhesion cohesion strength, no anchors, no glue, sticks to all the substrates. There's no airspace. It doesn't settle over time. It doesn't fade. You know, it's a great product when you look at it for long term. If you're building a new house, you want to live in that house for 30 years and be able to pass it on to your next generation. You know you're going to have energy savings forever in that home. Application: residential, commercial, industrial, agricultural, and others. Well, how many people have been to the Calgary Zoo? Anybody been to the Calgary Zoo? You've been out there? You know all the dinosaur park in the Calgary Zoo, all the rocks and the formations they have there? Well, that's wire mesh with spray foam over it, and then they just sprayed gunite on it to make it look like rock. That's how they make those big formations. So it's used in a lot of different areas that people wouldn't think that they would ever see it. They go, wow, I would have never thought that the zoo would have foam. A lot of those exhibit places where the monkeys are and different things, that's all spray foam covered with a polymer over top of those. And that's it. Thank you. Anybody have any questions that they'd like to ask about spray foam? Everyone's being shy. No one wants. Yeah. Oh, he'll bring you a microphone.
Well, the first question you mentioned about are you aware if there's a difference in insurance?
In your insurance? That I don't know. I've never inquired. is something I could probably look into.
Yeah, because you mentioned if you have that certification, which they put.
Yeah, for children's in school, for schools and hospitals. Yeah, Green Guard certified.
Yeah, no, you were mentioning where they, the certified guy comes in and what's that?
Oh, the certification. Yeah, it just says that it is sprayed and it's guaranteed. Kafka offers third-party warranty on the spray foam. We as a manufacturer offer warranty on the spray foam, and then the installer who installs it, the contractor, offers warranty. So essentially, you have 3 warranties on one product. So Kafka does a $50,000 warranty on the product. So, any other questions on spray foam?
Oh yeah. Oh, so we saw in Quebec. You said that they were doing both interior and exterior.
Yes, they are.
Do you need that here?
No, you don't. You can do strictly interior. You can do strictly exterior. You can do a combination of foam and bats. So there's quite a wide variety, especially in the commercial side. Mostly in commercial, we'll see spray foam on the exterior of the buildings, and then they use a bat on the interior, especially in schools. And it minimizes the cost because you want to air seal the building and create an air seal with 2 inches of foam, and then they bat the inside for the insulation value to bring the R value up to the standard because it's cost effective in a big commercial operation. In a home, not so much. You just want to know when the beer is. Just kidding.
Yeah, my question is, would the contractor be encouraged to use this product based on competitiveness in the market?
Based on which?
Competitiveness.
Oh yes, yeah. You have to realize spray foam is about 2/3 more in cost, but your energy savings are 30 to 60% over time. So you sort of weigh that out and go, well, I'm going to spend a little more. But when you compare bat insulation versus spray foam, yes, it's 2/3 more. But now you have to install a bat, and then you're going to put a vapor barrier over it. Then you have to acoustical seal it, and then you have to tape it. So really, the cost is about 1/3 more when you compare a wall assembly to a complete wall assembly, because we are an air barrier, a vapor barrier, and an insulation all in one. So the cost isn't that much more overall.
Hello. We're considering a radiant barrier as well. So.
A radiant barrier?
Yeah, like an armor foil or a similar product.
Oh, okay. Yeah, not really necessary when you use spray foam. If you were using bats, I would consider that. When you're using spray foam, it's not really required because, at R6 per inch, you exceed the potential for a dew point. The radiant barrier is really just to help pink insulation do a better job.
Well, it's not so much the moisture issue or whatever, it's just the infrared.
Yes.
Stop the infrared, make chamber gain.
Yeah, yeah. So you wouldn't have any infrared or UV penetrating through spray foam at any time.
Is it non-permeable?
Yes. Yeah. Any other questions? All right. Well, thank you very much for attending. Hope you enjoy the rest of the home show, and I hope it doesn't snow tonight. Right? Thank you very much. All right. Bye now.